Let's begin by exploring the crucial concepts of integration and deployment in software development. We will focus on how to connect different systems and efficiently deliver applications to users. Now, let's discuss the significant benefits of integrating the front end with the back end. This integration is absolutely essential for creating robust and dynamic modern web applications. First, consider data exchange, which is fundamental for any interactive and dynamic application. It ensures a smooth and continuous flow of information between your client and server. Next, we have scalability, which is a key factor for adapting to growing application demands. This allows independent development of front-end and back-end, enabling flexible growth. Another major benefit is the enhanced user experience that integration provides. It significantly improves interaction by offering dynamic and real-time updates to users. Finally, let's talk about security, a critical aspect of any application. Integration helps implement strong authentication and authorization, protecting your application's data. Let's now explore the various communication methods used between the front end and back end. We'll see how different applications interact with application programming interfaces or APIs. First up are RESTful APIs, a very common choice for web applications. These are generally recommended for building most standard web applications due to their simplicity. They efficiently use standard HTTP methods like GET, POST, PUT, and DELETE. Next, we have Graph, QLAP, IS, which are designed for more specific data needs. They are optimized for specific queries, allowing clients to request exactly what they need. This approach significantly reduces the problem of overfetching unnecessary data, improving efficiency. Finally, we'll discuss WebSockets, which are perfect for real-time communication. WebSockets provide instant, real-time updates, making them ideal for dynamic applications. They enable bidirectional communication, allowing both client and server to send data. Let us walk through the steps for setting up a Spring Boot API for our backend. We will cover the essential steps to create a fully functional backend system. First, you'll need to add the necessary dependencies to your project's build file. This includes web, data JPA, and H2 database starters for core functionality. Next, we define our data model, representing the structure of our information. You will create a user entity with fields like ID, name, and email. Then, we create a repository, which handles the essential data persistence operations. This uses JPA repository to simplify common database interactions for your entities. Following that, we will create a service layer for our business logic. Here, you implement the specific business logic, such as managing user data and processes. Finally, we create a controller to expose our API endpoints. The REST controller annotation helps expose API endpoints for front-end consumption. Let's examine the actual code for the core components of our Spring Boot API. We will illustrate the essential setup for a functional and well-structured API. Here we see the user entity, which defines the fundamental data structure for a user. This entity defines the user data model in the database, with the ID field automatically generated. This code snippet outlines the user class, including fields for ID, name, and email. Next, we have the user repository, which simplifies database interactions significantly. It extends JPA repository, offering CRUD operations for the user entity without manual coding. This interface extends JPA repository, giving us built-in methods for user data management. Now, let's look at the user service, where our application's business logic resides. This service holds the business logic, injecting the user repository for efficient data access. This user service class shows methods for retrieving all users and creating new ones. Finally, we examine the user controller, which exposes our API endpoints. It defines REST endpoints, injects the user service, and uses cross-origin for front-end access. This controller provides GET and POST methods to manage users via our API. Let's now delve into real-time communication using WebSockets in our applications. We'll understand this powerful protocol, which is perfect for building highly dynamic applications. WebSockets are a powerful communication protocol designed for establishing persistent connections. They enable full duplex communication, allowing simultaneous data flow in both directions. This allows continuous data exchange over a single TCP connection, enhancing efficiency. WebSockets are ideal for real-time updates, especially in interactive chat applications. Now, let's consider why you might choose to use WebSockets for your projects. They provide highly efficient and bidirectional communication, which is crucial for dynamic interactions. WebSockets significantly reduce latency compared to traditional HTTP request and response cycles. They support features such as live stock updates and engaging multiplayer gaming experiences. We will now compare WebSockets with HTTP to highlight their key differences. Understanding these distinctions is crucial for choosing the right communication protocol for your needs. Let's examine several key features to understand how these communication protocols differ. First, consider the connection type, which determines how data is exchanged. Then, we look at how data is exchanged between the client and server. Latency is another important factor, greatly affecting the speed of your communication. Finally, we'll compare their ideal use cases to see where each excels. Now, let's look at the characteristics specific to WebSockets communication. WebSockets maintain a persistent open connection for continuous and efficient data flow. They support bidirectional communication, allowing both client and server to send data. WebSockets offer very low latency, making them suitable for real-time interactions. These are best suited for real-time applications requiring instant updates and interaction. Now, let's consider the characteristics of traditional HTTP communication. HTTP operates on a request-response model where the client initiates communication. Data exchange is primarily from the client to the server, with responses sent back. HTTP typically has higher latency due to connection setup for each request. It's widely used for standard web requests, like loading web pages and forms. We will now explore the different stages involved in a CI/CD pipeline. This pipeline is key to automating the entire software delivery process, from code to deployment. The first stage is source control, where all your code changes are managed. This involves managing different code versions effectively using tools like GitHub. Next, the build stage compiles your code and prepares it for execution. It compiles the source code and resolves all necessary dependencies, often using Maven. After building, the test stage ensures your application functions correctly. Automated tests are executed to verify the application's functionality and catch errors early. Then, we have artifact storage, where deployable components are kept. This stage stores the deployable builds or artifacts in designated registries for later use. The deployment stage is where the application is released to its target environment. The application is released and made available in various target environments such as production. Finally, monitoring ensures the application performs reliably and efficiently after deployment. It continuously tracks the application's health and performance, identifying any issues post-deployment. Let's look at an example of a CI/CD pipeline using GitHub Actions. This example demonstrates automating the build and deployment process for a Spring Boot application. The pipeline is triggered automatically on every code push or pull request to the main branch. This configuration specifies that the workflow runs on push or pull request events to the main branch. The first job checks out the code and sets up Java development kit version 17. This code sets up the build job, checking out the repository and configuring JDK 17. Then, the project is built using Maven, and all associated unit tests are executed. These steps perform a Maven clean package and then run all defined unit tests. Finally, the application is deployed to a server only after a successful build process. The deploy job depends on the build's success and then executes the deployment command. Let's discuss how to effectively manage configurations within a Spring Boot application. We will explore flexible methods for handling various application settings and parameters. First, we have application properties or YAML files for centralized settings. These files provide a centralized location for all your application's configuration settings. They support different profiles, allowing specific configurations for development or production environments. These files make it very easy to manage common application configurations efficiently. Next, we can use system environment variables, especially for sensitive data. They securely store sensitive data, like API keys, outside your application's source code. This ensures your application remains portable and adaptable across different deployment environments. In Spring Boot, these variables are typically accessed using the @value annotation. Command line arguments offer another way to configure your application at runtime. They allow you to override existing configurations directly when the application starts up. These are particularly useful for making quick, temporary adjustments to your application's settings. Command line arguments take precedence over both property files and environment variables. Finally, Spring Boot profiles enable tailored configurations for different environments. They activate specific configurations automatically, depending on the active environment. You can use files like application-dev.properties or application-prod.properties. This ensures the correct settings are applied for development, testing, or production stages. Let's summarize the key takeaways from our discussion on integration and deployment. These are the essential concepts that you should remember for effective integration and deployment. Front-end and back-end integration drives dynamic user experiences and data exchange via RESTful APIs or WebSockets. WebSockets offer real-time, bidirectional communication vital for chat applications and live updates. CI/CD automates software delivery, enabling faster releases and early bug detection through pipelines. Cloud platforms such as Heroku, AWS, and GCP provide scalable and flexible deployment options. Environment variables and profiles manage configurations securely and adaptably across various environments. Docker and Kubernetes facilitate containerized deployments, ensuring efficient and streamlined configuration handling.